All right, everybody. Hello, my name is Phil, and I'm here to bring you the advanced portion of our introductory workshop. I'm also just going to be recording this and putting it up on YouTube, just in case anybody can't make it to the stream and you want to view this for later. I will put that up pretty much either tomorrow or at some point this week to make sure that you can review any of the content on here. All right, so I'm just going to turn on my webcam here. And I'll put it on top of the splash screen here. All right, cool. So for everybody that doesn't know, my name is Phil. I'm here at Blockcast Media, here to bring you pretty much the part 2 series of the introductory workshop to try to get you a basic knowledge, try to get you basically the base knowledge you need to understand the technology, and just some basic core concepts and a little bit about what's happening in this space. I think it's pretty important for people to learn about these things, and fortunately sometimes people will go out there and charge you a couple $100 just to learn pretty much same information that I'm going to show you here. So I'm just going to go right to it. I also have the Twitch stream open. If anybody has any questions, just note there's like about a 10 to 20 second delay between the live stream and also what I'm getting through Twitch here. So let me just turn on my, let's see, take the splash screen off and we'll bring you over to the slides. Okay, so welcome everybody. To this online workshop. Going to go right into it here. So the next slide here, today's agenda. We're just going to go into a little bit more of some advanced blockchain concepts. If you haven't already viewed the video beforehand, our basic introductory workshop, I would suggest going through that first, just so you sort of have an idea as to what we're talking about here and you're not fully lost. Okay. So we're going to go into a bit more of the advanced blockchain tech concepts, which is why I recommend going through the basics. We're going to go through some security practices. I'm going to give you a little more information about how to better store your private keys, your private phrases, and we're also going to dive a little bit into just a bit about cryptocurrency scams that are currently out there right now and how to mitigate those. We'll talk a bit about digital exchanges, and at the very end, I'm going to do a hardware wallet demo. As you would have known from the Basic Introductory Workshop, there are different types of digital wallets, and we're going to talk about more of a hardware solution for this webinar, just so that, because I think it's actually one of the more important wallets to understand, because you're going to be storing ideally most of your cryptocurrency and other digital assets within this device. Okay. Then we'll move on to what we already understand. So if you haven't gone through the workshop for the basic basic intro workshop, there's the link there. I will also actually just post you that link in the Twitch stream as well. Just so you can sort of bookmark it for later if you haven't already seen it. Okay. All right, so from that video, we already understand how Bitcoin blocks work, what sort of information is on it, how it all links to create the chain of blocks, which is the blockchain aspect of it, underneath what powers Bitcoin, basically. Know difference between public keys, private keys. We know difference between hot and cold wallets, what recovery phrases are, how to transfer digital assets, which we showed you the demo last time, and blockchain explorers. So that's a good foundation, but we're going to build on some of this as well. Because as we mentioned also in the last video, there are things such as network fees or gas fees that they call it that are very important to sort of understand here. So as you know, nothing in this world is free. So whenever you utilize the resources of a blockchain network of some sort, whether that be Bitcoin, Ethereum, or another one, anytime you utilize these resources, it costs money. And in Bitcoin, it's paid in Satoshis, which is basically the underlying currency of what Bitcoin is. In Ethereum, you pay in Ether. And the amount of it depends on what you're actually doing. So for example, if you're telling the Ethereum network that I just want to transfer one Ethereum from point A to point B, that's a pretty simple instruction to the network. So in terms of what you're going to be paying in network fees, it's going to be something that's pretty low depending on what the status of the network is. So the status of the network depends on, how congested is a lot of people using it right now. If so, then, the costs of actually paying these network fees will be higher. So there are two things that is important. It's both the gas price and the gas limit. And when we define gas price, it's basically done in what's called a first price auction model. So think of it as with gas price, it's kind of like when you go to the gas station and the question is how much is people paying per liter or per gallon for gas? So obviously the higher that you pay, the faster it'll process in the network. So the first price auction model works by whoever pays the highest gas price will get their transactions in a block before everyone else. Because if you're willing to pay more, the chances of you getting into a block will be a lot higher. Okay, but obviously there are ways to sort of understand what the status of the network is. So then you can sort of optimize what a gas price should be to get in within a reasonable amount of time. So one of those sites here is actually called ethgasstation.info, which we also went into last time to sort of determine what an optimal price range is. So Ethereum here, when you load up ethgasstation.info, it'll generally tell you based on the last 1,500 blocks what is going to be optimal. So you would always look down here on the right side, recommended gas prices, which will tell you what a good safe low gas price is, what a standard gas price would be to try to get in within like 5 minutes. And also if you want to get it in faster, like what's a good optimal price to sort of set it as. So that's basically a little bit about what gas price is. For Bitcoin, it's quite similar. It's just you'll use another site. I believe if you just Google something like Bitcoin transaction fee. BitInfoCharts has one that will determine sort of what the cost per Satoshi is right now to sort of transfer Bitcoin from point A to another. The difference with Ethereum and Bitcoin is basically if you are going to give more instructions to something like Ethereum, because Ethereum can do a lot more than what Bitcoin can in terms of instructions due to smart contracts and all of that. You can execute more instructions, but that'll cost you more because you're telling the Ethereum network to do more than just transfer Ethereum from point A to point B. Whereas Bitcoin's a little bit easier. Like right now, what is it, like 13 cents they've converted it to US dollars to try to give you an idea as to how much per Satoshi you'll be paying. Bitcoin transaction fee per byte. We'll probably get you something right now. Bitcoinfees.earn.com will be able to tell you something a little bit better. So based on some of these blocks here, you can see generally what is a reasonable rate that you'll be paying. 9 to 10 Satoshis per byte right now would probably get you in about 0 to 30 minutes for your transaction to confirm. So that's an example of what the gas price is, and it works with that model. So obviously, the more you pay, the faster and the likelier you'll get your transaction in within a certain time frame. Now, for Ethereum, you're going to be dealing with something that's called a gas limit. So this is not necessarily the price at the gas pump for your car, let's say. This is more of, say, how much can your car's gas tank hold? That's sort of like your limit. There's only so much gas you can put into a gas tank. So what the gas limit does is it helps prevent things like bad code from costing you a lot of money. And also prevent something called infinite looping, which is basically when a computer executes instructions in a loop and it doesn't stop. So these sort of things were put in place basically to ensure that if you tell the Ethereum network not just to do an Ethereum transfer from point A to point B, but you're, say, telling it, hey, go to this smart contract and tell the contract to perhaps send or transfer tokens from this address to this address, you're telling the Ethereum network to do a lot more. And what the gas limit does is it sort of limits the ceiling of what this costs, so that if you have a bad instruction, it doesn't go, eating away at your ether as you're putting into the transaction there. So the gas limit, as you know, the more instructions that you tell Ethereum to do, the more gas you're going to have to put into it. So if you're not telling the Ethereum network to just transfer one Ethereum from point A to point B, but you're telling it to now go to a smart contract and tell the smart contract to do something, it's going to cost you more. So you'll end up spending more gas. So the way to basically figure out like how much it'll cost you is basically what sort of instructions you're going to be telling the Ethereum network to do, and then you multiply that by what kind of gas price you're willing to put in, and that's usually how you figure that out. So in essence, changing the gas limit won't actually do much to say how much you're actually going to pay in transaction fees, right? Because when it comes to the transaction fees, if you're just telling Ethereum to transfer one ETH from point A to point B, that's one set of instructions. If you change the limit on that, it doesn't really matter because you're only giving it one specific instruction. What matters is the gas price, because if you want this one instruction to basically go in faster, perhaps into the next block, you'll pay a higher gas price. Or if you don't mind, perhaps waiting a little bit more than like 5 minutes, you can pay a lower gas price to try to make it just a fraction cheaper. So that's sort of what the gas price and gas limit difference is. There is a really, really good guide from MyCrypto that actually explains this concept in a pretty easy to understand way, I would say. And I'm just going to post this into the Twitch chat here as a link. I'll also put these links up on the YouTube page as well, just so you can get quick access to this information. Okay, so moving on from gas price and gas limit, we're going to go into a really nice diagram of what happens sort of under the hood. So MyCrypto created this amazing diagram to describe what you're actually doing when you're sending a transaction into the Ethereum network. Okay. So at the very top here, you're going to see that you sign and you send your transaction through MyCrypto. You say, I want to transfer one Ethereum from one point to another. When you sign that transaction, it goes and it puts it through into the MyCrypto node. So MyCrypto has a bunch of nodes that basically are connected to the blockchain and continuously broadcasting transactions out into the network so that they can get put into a block. So it goes down this this slide of fun, as they've described it, into a big pool of transactions. So all the people who are sending transactions into the Ethereum network, they all get put into this big pool of signed transactions. Now the miners, the people who are actually processing these transactions to put it into the next block, pick obviously the ones with a higher gas price first, because they're incentivized to obviously make the most money, and the people who are paying the most money to get a transaction included are the people that are putting their transactions in with a higher gas price. So those ones get picked from the pool first, and then miners put it into a transaction, and then it gets added into the blockchain. So this is very similar as to what Bitcoin does as well. The only difference here is you're not really using my crypto. I mean, when you think about the pool of transactions, it's basically the same thing with Bitcoin. When you broadcast a Bitcoin transaction out, you get put into a pool of other Bitcoin transactions, and people basically the transactions that get picked up first are going to be the ones that have a higher Satoshi per byte, which is the same thing as gas price. It was really interesting because back in 2017, when things were really picking up and all the networks were starting to get congested, you can see that there were tons of pending transactions. So this pool would have been huge, and it would have been full of all these transactions that couldn't just, get put into blocks because there were so many of them. And these networks are still so early that they can only process a certain amount of transactions per second. So they were getting overloaded with a bunch of transactions in the pool. Not enough people are taking transactions out of the pool to put them in blocks, but there were more transactions actually coming into the pool than it can handle. So it's very interesting. We'll probably just try to Google this quickly, but you can definitely see what the pending transactions are in something like Bitcoin and Ethereum. I would say Bitcoin is usually a better example because it is a slower network. So you'll probably see more unconfirmed transactions here. So blockchain.com has a great site that basically tells you how many unconfirmed transactions are waiting in the pool to get put in to the next block. So about 740 something transactions right now. Back when during the big crypto boom in 2017, this number, wow, I probably remember seeing it in the hundreds of thousands when it was really clogged, if my memory serves me right. But as you can see, the network is not very clogged. I wonder if there is some sort of a historical one that we can quickly look at. Another way of calling this is also mempool. Okay, so let's look at the chart for the last year. So the mempool is the pool that I was basically talking about, where all the transactions are sort of residing. So yeah, so I do remember seeing it at it was December 2017. The highest was 177,967 pending Bitcoin transactions. This was when the network was really clogged and really slow. And, with the way the first price auction model works for gas prices, it probably meant that around this time, your transaction fees were going through the roof. It would have cost you tens, maybe even hundreds of dollars just to sort of get a confirmation on your Bitcoin transaction in a reasonable amount of time. Okay. Oops. Close the wrong one. Okay. We'll just close the mempool transaction here, and we will reopen the PDF with the slides. There we go. Okay, so moving on. I'm going to quickly talk about mining. So you've all heard of the concept of Bitcoin mining and just cryptocurrency mining in general. So what the miners are doing is they're sort of the people with the hard infrastructure to actually process and create the new blocks on the network. So as a cryptocurrency miner, let's just say Bitcoin, the mining economics is pretty simple. You want to be able to make a profit on putting resources to help the network function. So if your mining reward is greater than the cost of the hardware itself and the electricity costs, it's definitely worth it for you to join the mining network. So these are things that a lot of the miners think about, their fixed and variable costs, to make sure that it's profitable for them to contribute their resources to the network and make some money. That money, the block rewards, which we'll go into later, which comes from mining cryptocurrency, is sort of what incentivizes these miners to put up their resources and resources such as hardware and electricity to be able to keep the network running. So a lot of these, we'll talk about this as we go on, about a lot of these rewards and how likely you are to find the next block and all that stuff really depends on the global hash power that goes into it. So the amount of energy that goes into trying to solve this cryptographic puzzle. Okay, so we're just going to go into very quickly an overview of the two most popular types of mining. So proof of work mining is the one that you've probably more likely heard of. It's basically what started with Bitcoin. And proof of work mining is basically using hardware such as your CPU or your graphics, your video card, and now very specific devices to solve the cryptographic puzzle to win the block reward and be able to make a profit, basically. Excuse me. So back in the early days of Bitcoin, it used to be you used to be able to reasonably find the next block with a graphics card, so like an idling gaming computer in someone's home. But now, because so many people are contributing to this network and to try to find the next block, it's become almost impossible now for people to make money off of video card mining, because there's just the likelihood of you being able to find the block is so minuscule now with just a video card that it's not worth it to try to basically just put your resources up and your video card up, basically to try to basically make some money off of Bitcoin. There are specialized devices out there now that have been built that focus on specific cryptocurrencies like Bitcoin to basically give a user a much better chance of finding the next block. So your graphics card alone at home now will unfortunately not be enough to make something like Bitcoin mining work. So different cryptocurrencies have different algorithms when it comes to solving this cryptographic puzzle. So Ethereum is different from Bitcoin, different from a bunch of other cryptocurrencies. SHA-256 is the algorithm for Bitcoin, and Ethash is the one for Ethereum. So if you have a specialized device, like what they call ASIC devices, which stand for application-specific integrated circuits. It's basically just like a box that is built specifically to mine Bitcoin, for example, which would be the SHA-256 algorithm. Something like that is very, very specific to just Bitcoin. You wouldn't be able to use something like that to, say, mine Ethereum with it. And as you may have heard on the news and everything else, it's very, very energy intensive. So obviously it has to be feasible for someone to spend all that electricity, all that energy on the device to basically mine Bitcoins, and which also creates like a huge environmental problem, as you may know. Proof of stake is a different type of mining. Basically, it's basically instead of contributing your hardware resources and your electricity to try to solve the cryptographic puzzle, what happens is now you are using a computer to basically vote on blocks. And how you do that is by putting in a deposit, an economic deposit of, say, a cryptocurrency, to basically vote on these blocks and to keep the network secure. So you can already see that that doesn't require something like a huge mining farm to do or anything like that. Proof of stake, staking is what they call it, is a lot more energy efficient and doesn't have that sort of initial hardware cost, but it does require you to put up front a bit of money to basically vote on blocks, and from that is how you win block rewards now. So just a different way of coming for all the different computers to come to consensus on what has actually happened on the network. So it rewards people who are honest by having them, say, make a small interest on their cryptocurrency when they put it up for staking. And there are some that are also designed to hurt the people who are basically not following the rules. So that's called something like slashing. So obviously there is an incentive for someone to, or for people to be honest in the system, or else you're going to lose your deposit. So those are the two different types of mining. We'll probably start seeing a lot more of proof of staking in these new systems rather than proof of work. But these are two of the most popular algorithms, or sorry, not algorithms, but rather different types of mining there is out there for cryptocurrencies. So what incentivizes people to put up their resources to keep the network secure is by offering them a reward. So every time somebody finds a block, they are rewarded in that native cryptocurrency. So for Bitcoin mining, you are rewarded in Bitcoin. Right now, 12.5 Bitcoin for every block. And for Ethereum, it's 3 Ethereum for every block. So the way that Bitcoin works is when it started out in 2009, anytime somebody found a block from mining, they were rewarded with 50 Bitcoin. And the way the system is designed is every 4 years, this reward gets smaller and smaller. So you'll hear a lot of people saying that Bitcoin is a deflationary asset, deflationary currency. They are definitely correct, because every 4 years, that prize basically gets smaller and smaller and smaller. So there's only ever going to be so many Bitcoin created, and it's only getting more scarce as every year goes by. So in about, I believe it's May of 2020 is what's called the halving. So every 4 years, it gets cut in half. So it was already cut down to 25 Bitcoin, then the halving cut it down to 12.5 Bitcoin, and then the next halving in May 2020, it's going to be half of that. So like 6.25 basically. And by the year 2140, all of the 21 Bitcoins that will ever get minted will be out by then. So it's basically it's like a graph that kind of goes, let me see if I have it in here. I don't believe I do, but anyways, if you Google it, let's try Googling it right now. You'll probably see how this graph looks like. Bitcoin issuance chart. basically looks like this. Bitcoin inflation versus time. Okay. So going on, solving these puzzles requires hash power. And that's what everyone's trying to do, is they're trying to contribute their hash power to the Bitcoin network and the Ethereum network to basically try to find these blocks so they can win the reward. And the more hash power there is, obviously, the easier it would be to find the puzzle, wouldn't it? It would make sense that if we all contribute our resources and put them all together to try to solve this puzzle, it should be easier, right? Well, the thing is, Bitcoin and Ethereum are designed with something called difficulty. So this difficulty readjusts itself to make the puzzle a little bit harder every time there is more hash power put into the network. Because the ideal block time, which is the amount of time it takes for the next block to get published or found, is about 10 minutes on Bitcoin and about 15 seconds in Ethereum. So they want to try to keep it to these times. So if someone finds a block, but it took, say, 7 minutes instead of 10 because we had the hash power to find this or to solve this puzzle in a lot faster time, what this difficulty does is it makes the puzzle harder so that perhaps in the next block, it'll be targeted at 10 minutes. So with Bitcoin, this difficulty actually readjusts every 2016 blocks. So that's every 2 weeks. It sort of analyzes the hash power of the network and like how fast people are solving this cryptographic puzzle, and then it makes it a little bit harder or it makes it a little bit easier. So a good way to sort of see what this hash power is actually there are some sites out there that will show you what the global hash rate is. So I believe BitInfoCharts has a graph that will allow us to see what the hash power is for Bitcoin. It is very high. I believe it hit like a record not too long ago. So you can see more people are contributing resources to basically secure the network and to find these new Bitcoin. So it gets harder and harder every time this hash rate keeps going up. Let me see if I can zoom this out, maybe perhaps for 1 year. You can see that Bitcoin in general has just always been getting harder and harder to find this Bitcoin block because more people are trying to solve this puzzle at the same time. So even though you see the prices of Bitcoin dropping, I mean, the amount of resources that are being contributed to the network is actually growing. So that's a pretty interesting factor to keep in mind there. I believe Ethereum also, we can also see the hash rate of Ethereum as well, which is nowhere near Bitcoin. There we go. Yeah, you can see like some pretty good growth in Ethereum, but it's sort of stabilizing around 280 terahashes right now. So that is what hash rate is. We'll keep going forward. Yeah, so for Ethereum, in terms of the difficulty, it gets readjusted after every block, whereas Bitcoin, it's every 2 weeks. Okay, so we're going to move on now to smart contracts, because that's sort of like the 2.0 of Bitcoin after Bitcoin was sort of released out there, and then Vitalik Buterin came up with the concept of, say, smart contracts for a blockchain. So what smart contracts are that they're basically programmed to autonomously exchange value between parties without an intermediary. So what that means in easy terms is it's basically a coded contract that says um, simply if these conditions are met, this thing should happen. Is a very simple smart contract. But what it does is it allows you to sort of agree upon coded contracts that doesn't require a third party intermediary, like say a lawyer or an escrow, um, to be able to execute these contracts. Um, so that's sort of like a 2.0 of what a blockchain can do. And a good example of what smart contracts are and what they're capable of is the example of tokens, and how people have been basically creating these cryptocurrency tokens to say give out to try to raise money. This is what you may have heard as initial coin offerings. So what those are is it's actually just a smart contract that lays out what accounts have X amount of this token, and then what can we do with this token? We can like transfer it. We can tell it to perhaps create more, or but that's sort of like an idea as to what a smart contract is. Speaking of tokens, the ERC20 token standard is a standard of how to basically have a Ethereum-based token. It lays out a standard protocol of what sort of information is required on there. So it's basically a smart contract that maps Ethereum addresses with X amount of tokens. So whenever you're transferring tokens around, let's just say a golem token, you're actually going to the smart contract that knows everything about this token and saying, hey, I want to transfer 20 golem tokens from this address to this address. And that's what these smart contracts are capable of. Anybody can go out there now and just deploy your own token. It's been done so many times now. You can see that there's already like, I believe, over 1,000 different types of tokens out there, and a good chunk of them are ERC20 tokens, which is basically Ethereum-based tokens. Another sort of breakthrough, I guess, is sort of like a token 2.0, perhaps, is another standard that recently just got standardized called the ERC 721 token. So this is basically a non-fungible token. So every token is actually unique from another token. Let's just say we had like 20 golem tokens. They're all the same. They all represent really the same thing. They're just golem tokens. But what these non-fungible tokens allow you to do is now you have unique coins that are being created. So if you've ever heard of something called CryptoKitties, where you are able to own a very specific type of CryptoKitty, which only you hold, right? There's never one that is sort of the same as yours. It's almost like baseball cards, except there's maybe only like, as long as it's not replicated like the same, or even like Pokemon cards, like there's only a limited amount of say a certain Pokemon. This is a pretty big breakthrough because now it allows you to create these kind of unique digital assets, which basically work in so many different ways. Like I've heard of them being ways to perhaps have X amount of special items in a video game or something like that. You're able to do stuff like that with these non-fungible tokens. But that's sort of what the power of smart contracts can do. And people every day are figuring out new ways to use smart contracts in a way that has never actually been done before. So some of these decentralized applications, which Ethereum allows, well, I wouldn't say that, but the Ethereum platform basically enables, is a bunch of different cool ideas out there that basically don't require intermediaries to do the same things that we're doing today. Like, for example, LivePeer. LivePeer is a decentralized video streaming sort of protocol where it basically kind of works like Twitch, except you don't need Twitch anymore, which is a pretty cool concept. People are tokenizing gold. There's 0x protocol, which is creating protocols for token transfers directly between person A and person B without needing to go through a centralized exchange, for example, which is pretty cool. There's like Civic, Uport. They're doing like, decentralized identification, which is really cool. There's a lot of different projects out there, but it's really amazing to see how these applications are sort of enabling us to, take back our information and so that we can control it and not necessarily giving it to say Facebook, who is a centralized social network service that has all of our information and is able to, mine that for, advertising, for example. But there's a lot of cool stuff out there, which I won't go too far into because I want to keep this webinar stalled on just DApps. That could be for another webinar at some point. I'm going to go a little bit into security practices now, just because security is probably one of the most important things. As you know, blockchains are immutable. So once something happens, it's actually very impossible almost to reverse something that has happened on the blockchain. If person A sends person B 1 Ethereum and say, oh, I changed my mind, I want to take it back, like that is not a possible thing, which is why security is key, because once you make a mistake once, it can cost you, and there's not a lot that somebody can help you do except allow you to be a little more informed about what you did wrong, and so we can fix it and doesn't happen again. Okay, so one of the biggest ones actually is phishing attempts. Phishing attempts is basically what it sounds like. It is trying to phish for people's cryptocurrencies where they're tricking them into, say, clicking a link to a fake website or something like that. Yeah. So these are one of the most common cryptocurrency scams out there. A lot of them includes, utilizing search engines like Google. As you can see, there's an example of a fake My Ether Wallet website. If you look a little closer, it says myetherwallets.com, and it's obviously an ad here that somebody paid to put on Google to try to trick people into going to a fake My Ether Wallet website. These are like little things out there that, actually cost people a lot of money because they're not informed about what to look for and what to do when it comes to security. So the best advice that we can give is basically stop trusting links, especially those link shorteners like bit.ly and, any of those ones that sort of make long website addresses smaller. Stop trusting that in general. Always sort of try to type everything yourself. You know what the MyCrypto or the MyEther Wallet website is. Just type in mycrypto.com, myetherwallet.com. Don't trust a Google search engine to do it for you. A little cool thing that I also learned is that for those link shorteners, if you actually add a plus symbol to it, you can actually see where the link goes to and a bit about the statistics about where it's directing people and how many people have clicked the link. So this one is an example of a, hang on, I'm just going to copy this here and put it up. An example of a shortened link that took you to a fake, I believe, My Crypto website or My Ether Wallet website. Okay. 1 second. Okay. Hang on, I'm just going to cut this off here because I believe there's something wrong with the Twitch stream, and I'll be right back as I figure this out. 1 second.